If you could have any superpower, what would it be? For one species of octopus, the answer is easy. Imagine you're an octopus in a predator-filled sea with no natural defense. Now imagine you're the mimic octopus, and you have the power to completely morph your appearance. The octopus was discovered by scuba divers off the coast of Indonesia. Norman, Finn, and Tegenza spent 16 days observing 9 of these octopuses in the Indo-Malayan waters. The octopus lives on open seafloors without many places to hide. Instead of using camouflage, they use a form of mimicry to imitate other sea creatures. They use their flexible bodies and color-changing skin to shift their appearance, thus tricking predators and increasing their fitness. The mimic octopus uses Batesian mimicry. According to Fennig, 2012, Batesian mimicry is when a harmless species evolves to imitate a harmful or inedible species to avoid predators. This octopus can mimic several harmful creatures, such as the lionfish, banded sea snake, and flatfish. Norman et al. 2001. When mimicking the lionfish, the octopus spreads its arms wide and allows its arms to trail behind it when swimming. It imitates the lionfish's venomous spines and striped appearance. When mimicking the flatfish, the octopus flattens its body and pulls its arms tightly together and glides along the seafloor. When mimicking the banded sea snake, the octopus hides 6 out of its 8 arms while leaving 2 arms out in the opposite directions. It creates a banded pattern and imitates the sea snake's undulating movement. This octopus demonstrates phenotypic plasticity, which is the ability to change its phenotype in response to its environment. It also displays behavioral flexibility to avoid phenotypic constraint. Research by Hanlon, Watson, and Barbosa, 2010, on a related Atlantic species, Macrochittopus dephilippi, showed that mimicry is a dynamic conditional response. These octopuses didn't mimic constantly, but mimicked flatfish only when moving through open water. Hanlon and colleagues found that octopuses use mimicry as a primary defense in exposed environments. Not only did they imitate shape, but also swimming patterns, speeds, and action. Hanlon et al. 2010. Norman and Hochberg, 2005, used DNA sequencing to trace the development of the mimic octopus's traits. They discovered a 3-stage evolutionary process. First came the ability to quickly change from camouflage to brown and white stripes. Second was the octopus's ability to lengthen its arms and its flatfish swimming pattern. Lastly, the octopus combined all these traits to form the complex mimicry it has today. Huffer, 2010, investigated this mimicry using phylogenetic analysis to trace the evolution of behavioral and morphological traits between related species. Hufford found that flatfish developed around the same time as a mimic octopus. And this suggests that the swimming pattern and body shape co-evolved together and that the mimicry was shaped by natural selection. Fennig, 2012, discusses that mimicry is proof of natural selection's ability to promote adaptation. Natural selection can favor phenotypic convergence between unrelated species. Mimicry supports evolutionary fitness by reducing predation risk and highlights how evolution favors behavioral flexibility. Over generations, individuals better at deception survive longer and produce more offspring.
to return to the surface and chew this all over. What I came out for was I thought a dead cert. I'm going to see a funky octopus.